line, you need that. Let me charge it. The battery is crying now. Yeah, it's been working for quite some time. I didn't even put a charger since morning. Or I put a little bit. Yeah. Alright. So first thing we need to calculate the gradient of the line. So you can read all the information that's also there on the diagram. Right? Everyone, I hope you remember how to calculate the equation of a straight line. Okay? You know that the equation of a straight line is in the form y equal to m. The other thing that I also aware is that in metric, because we have done from grade 8 up to now, we have got some background of most of the mathematical concepts. Okay? And in most cases, you just have to refresh yourself. So the general equation of a straight line is y equal to mx plus c. You know that m is the gradient, c is the y-intercept. Okay? So you're going to calculate the line, the gradient of line AC. You go to the diagram, that's point A, you know the x and y value. Point C, you know the x and the y value. So our gradient for AC is going to be y2 minus y1 over x2 minus x1. Now it is your choice to decide which one you want to make your y2 and your x2. I'm going to choose point A. So the 12 is going to be my y2. My y1 is going to be minus 9. It's your choice. Okay? So that will be minus 9 in the brackets all over. My x2 is going to be minus 9 and my x1 is going to be negative 3. So this will give me 12 plus 9 over minus 9 plus 3. So you end up getting 21 over minus 6. And you can simplify this and write as minus 7 over 2. Okay. So your gradient for AC is negative 7 over 2. So you have to show that step the 12 versus 9. Okay, if you don't want to show it, it's fine. But I would prefer to show it. So someone might ask me, how did you end up coming to 21 over minus 6? Right. Okay, the mark can be using the gradient formula and the substitution 1 mark, the final answer 1 mark. So that step that you're talking about, it helps to get the answer, but this is not allocated a mark. Okay. So this is the first part. And this is actually a grade 9 and 10 question. Right? And the next one, determine the equation of the line RNS. So your line RNS, this is point R, right? That's point N, okay? And that's this point S. Okay? So we need to find the equation of that line. Now, we have to go back to the original question so that we can see if there is any information that will help us to do so. Are we told that, okay, this is very important. So we are told that such that RNS is parallel to AC. So these two are parallel, which means their gradients are what? Are the same. Hey, you need to pay attention. They are parallel, so their gradients are the same. Alright? Now, the question will be now, if I want to find the equation of RNS, I don't have any coordinates for point S, no coordinates. In fact, I've got the y value for point N, don't have coordinates for point R. Okay? I'm sure you can see that. Right. Now, the straight line passes through this point here. What is the name of that point? It's the origin. It's the origin. What did I say about a straight line which passes through the origin? The y-intercept is equal to what? 0. No. Yes, 0 is Listen, this equation of a straight line y equal to mx plus c. If the line passes through the origin, what's the y-intercept? 0. It's 0 because the straight line passes through the origin there. So this c here is equal to what? 0. Therefore, the equation must be of the form y equal to mx. Okay? So we know the gradient. It's equal to the gradient of what? AC. So all we have to do is substitute the gradient here, which means the equation of that line is not y equal to minus 7 over 2x. And my suggestion as well is also to write that mRNS is equal to MAC. Therefore, mRNS is equal to minus 7 over 2. Then you can write, therefore, the equation is that. Are you following there, Rishabh? The two straight lines are parallel, therefore their gradients are equal. But for straight line RNS, the y-intercept, we cannot calculate it. There is no way that we can calculate it. But the good thing is that the straight line is passing through the origin. So we know that if a straight line passes through the origin, its y-intercept is a 0. Okay? Therefore, C is going to be 0 here. We just put the value of m is minus 7 over 2. That's your equation. So then you have to write the gradient that AC minus okay, you can write here AC, this AC is parallel to RNS. Therefore, mRNS is equal to MAC. It's 2 marks, so 1 mark is for the equation, the other mark may be for finding the gradient of RNS. Okay. When you did the question, what answer did you get? Alright, any questions? No, sir. No. Okay? Yeah. Then 3.3, calculate the value of A. A, you see this A here, is the value of x at that point. We now know the equation for RNS. Okay? We know the x value here. So the y value is 7. And the y value is equal to what? To A. So how would you carry on? We know the equation for the straight line. We know the y value at that point. We don't know x. We just substitute. So our equation is y equal to minus 7 over 2x. Where there is y, we put what? 7 there. Right? The denominator there is a 1. Then you cross multiply, you get 14 equal to minus 7x. Okay? Then you divide both sides by minus 7. So you get x equal to negative. That's a 4 mark. No. Because here, just equating, okay, substituting that y equal to 7. Just for using that. You get 1 mark. The simplification 1 mark. But this question, I think they allocated too many marks. It's so easy. It's so easy. They allocated too many marks. Okay, any other question? Don't get a question. Let's move on to the main one now. Angle of inclination. Right. You need to calculate theta. Theta is that angle there. Okay. Now this one is 5 marks. It means there is a lot that you have to do. But before I do it, I just want you to be aware that In grade 11, you learn this. Your angle of inclination, okay? In my class, I told you the definition for angle of inclination. The angle of inclination is an angle between the x-axis and a straight line. Okay, you have to know this before you start doing the question, right? It is measured in an anti-clockwise direction. From the x-axis. Okay? So in our diagram, that theta is not the angle of inclination because it's not an angle between the x-axis and a straight line. So you need to remember what the angle of inclination is. Right? Now there are two cases when the gradient is positive. When the gradient is positive, we have something like that. So the angle of inclination will be that. And we use the formula m equal to tan theta. M equal to tan theta. To calculate it. This is when m is greater than 0. Then, when m is negative, you have a line like that. That's your angle of inclination. So that's theta. For this case now, we use the equation. This is m is less than 0. We use the equation theta equal to shift tan of m gradient. We use the equation theta equal to shift tan of m plus 180 degrees. So you need to remember this. Here m is less than 0. So before you answer that question, you need to be aware of this. You have to know your definition of angle of inclination, the two formulas that are used to determine the angle of inclination before you start answering the question. Okay? So this is more like a recap of what you have done. That's why I give you the grade. So make sure you are familiar with it. And usually, when you have a grade 11 question, you have a question on angle of inclination. So you have to know this. It's theta equal to shift tan m. So that minus 1, shift tan m plus 180. Okay? Then, once you are aware of that, let's do the question. Now, this question here, it's a little bit complex. Okay? But it can be done. So if you want to find this theta here, this is how I'm going to do it. Already, I know the line, the gradient of AC. Am I right? So I can find the size of this one. Okay? Also, I may need to find the gradient of BC. Fortunately, I know the coordinates of what? Of BC. So that I can find the size of that angle. Right? Now, this angle here is vertically opposite to that angle. Okay? And this angle here is going to be equal to this angle theta plus this angle. You are you following that? Yeah. You remember your geometry of straight lines, vertical opposite angles? Yeah. So that's what I'm going to do. So first thing, I'm going to calculate the gradient of line BC. We'll use that to determine the size of angle MPO, or sorry, MPC. So I'll say MBC is going to be equal to y2 minus y1 over x2 minus x1. My y2, if I take the coordinate of D, it will be 9 minus 9 over 9 minus 3. So that will give me 18 over 12, which is 3 over 2. Yeah, what the question asked? So when you're answering a question like this, 5 marks, it's not easy to get those 5 marks. You must have a strategy as to how you are going to approach them. And what angles do you want? No, I'm just starting. I need the gradient of BC for me to calculate this angle here. That angle, let me call it alpha. Okay? Let me call it alpha. And this one here, I'll call it beta. Okay? Make things easy. Right? So, since I now know the gradient of BC, and the straight line is a positive gradient, it means I can find that alpha by using the equation m equal to tan alpha. Okay? Which means my alpha is going to be equal to shift tan of the gradient. What is shift tan of 3 over 2? Yes. 3, 1. 3, 1 degrees. So that's what. Okay. MPC is equal to alpha because they are vertically opposite angles. This angle here, alpha, is equal to that angle because they are vertically opposite. So what this means is that MPC is going to be equal to 56,31 degrees. Is it making sense? No, they are vertical opposite because line BC and the x-axis, they intersect together. See that the x-axis and line BC, they intersect this point here. Therefore, angle alpha and MPC are vertical opposite. Therefore, they are equal. This question I want to be aware that is level 3-4. Okay, it's a higher order question. Maybe that's why the other question is wrong. Alright, then let's move on to AC. I now want to calculate the size of angle beta, which you can call ABP if you want. You can call it ABP, but I called it what? Okay. Beta is going to be equal to this angle plus that angle because beta is the exterior angle of triangle MCP. Remember last in grade 8 we did the exterior angle of the triangle? Yeah. So let's move on to the next page. Next page I'm going to use the gradient of AC. And the gradient of AC, you got it as what? Minus 7 over 2. Okay? Am I right? Yes. So I'm going to move on to the next page. It's the same question. right? The gradient of AC is equal to minus 7 over 2. Therefore, beta, which beta is going to replace this theta in this form. Because in the diagram, I already have theta. So I can't use theta twice. You follow what I'm saying? Yeah. You see this equation here? Because the gradient is negative. We have to use this formula here. But this is a general formula. For our question, we already have theta. See this theta here is given. So I can't use theta again for the second time. That's why I used beta. Okay? So from there, this means beta will be about shift time of minus 7 over 2 plus 180 degrees. What answer do you get? It must be an angle under 90. 105 or 95 degrees. You following what I'm doing? No, you don't add. Exterior angle. I use the fact that the gradient is negative, that's why I use this formula. So I now know the value of beta. Okay, I know what alpha is. Okay, now beta is an exterior angle. It's going to be equal to angle P, so MPC plus theta, because it's an exterior angle. You see this angle beta here? It's an exterior angle of a triangle. Therefore, it's equal to this angle here, MPC. MPC is equal to alpha. Okay, MPC plus theta. So beta is going to be equal to MPC plus theta. Or I can say MPC, I can say beta is equal to alpha plus what? Theta. The same thing. Oh, so that's alpha. Oh. Okay, look here. You did this. Okay, you did this already. You see, when you have got a triangle like this. Yeah, what's it? Yeah, what's it? Yeah, what's it? So I use that. So I use that concept here. Angle beta. So beta then equals to beta minus alpha. So it's theta equals to alpha. You have beta minus alpha. So my stuff is below. Okay, it's close. Right? So please say it's equal to. So can you give the answer? This one. So we are saying this angle here. Do you agree with me that it's an exterior angle of a triangle? Yes. Therefore, it's going to be equal to this angle MPC plus theta. Right? So we take on from there. So I'll say beta is equal to MPC plus what? Theta. Theta is 105, 95 degrees. So that's what I say. MPC 56,31 degrees plus theta. Therefore, theta, you take the 56,31 to the left, you get 105,95 degrees minus 56,31 degrees. What answer do you get? 49,64. 49,64. It will change, but you switch again, this time you will remain the same. You see, okay, what I could have done was take this 56,31 to the left, right? Whatever difference we get between these two is going to be equal to this value. You'll be left with the theta on the right. which is positive. So if you swap the two, both become negative. Then you divide both sides by minus 1, you end up getting positive answers. Alright? Thank you, sir. Right.